Science 10, Lesson 9, Naming Acids. Naming acids. Over the past few days, we've been looking at ionic compounds. Acids are also ionic compounds, but they behave very differently than the average ionic compound, and for that reason, have a unique naming scheme. The cation in an acid is always H+. This means the only difference between acids is the anion. Therefore, acids are named based on the anion found in the formula. Have you ever noticed that all the negative ions on the common negative ions list either end in ate, ide, or ite? On your formula sheet, you need to find the acid naming box. When the anion ends in ide, we add the prefix hydro, we change ide to ic, and then we follow with the word acid. If the anion ends in ate, we change ate to ic, and then follow with acid. And if the anion ends in ite, we change ite to us and follow with the word acid. We have to keep in mind there is an exception in suffix when it comes to the sulfur and the phosphor acids. That will come up later in this lesson. To remind ourselves that acids always involve H+, I would recommend on your formula sheet writing H+ next to the acid naming title. Example 1, H2SeO3. I've got two H pluses on the front, so SeO3 must have a -2 charge. I look up SeO3 2- on my negative ions list, and I find the name selenite. It ends in ite, so I change ite to us, and I follow with acid. So H2SeO3 is called selenous acid. Example 2, HOCN. I have H on the front, just one, so that means the OCN must have a -1 charge. So I go to my negative ions list and I look up OCN, minus, and I find cyanate. Since it ends in ate, I change ate to ic and follow with the word acid. So HOCN is called cyanic acid. Example 3, HCl. I have one H, so that means the Cl has a -1 charge. I look it up on the common negative ions list. It's called chloride. Since I have an ide ending, I add the prefix hydro. I change ide to ic, and I follow with acid. So HCl is called hydrochloric acid. Example 4, H2S. I have two hydrogens, so the S has a -2 charge. So I look up S2- on my negative list, I find sulfide, which ends in ide. So I have to add the prefix hydro. I change ide to ic, and I follow with acid. And that gives me hydrosulfic acid, but it's not boxed, and that's because it's not a final answer, because at the very bottom, remember, we have an exception in suffix when it comes to sulfur and phosphor acids. I need to add a right here. And that gives me then hydrosulfuric acid. Example 5, H3PO3. I have three hydrogens, so that means the PO3 has a -3 charge. When I look it up on my negative ions list, I find that it is called phosphite. Since I have an ite ending, I change ite to us and follow with acid. And that gives us phosphorus acid. Oh, that again doesn't sound right. Oh, the exception in suffix. So I have to have an or added right after the phosp. And that gives me then phosphorus acid. Phosphorus acid. That sounds better. Example 6, arsonist acid. I have us, So that means the original ending would have had to have been ite. So I'm going to revert us back to ite and then take off the acid that was added to the name. And that leaves me with arsenite. So I go to my common negative ions list and look up arsenite, and I find that arsenite is AsO3 with a 3- charge. Since it has a 3- charge, I will need 3 H pluses to come before the anion to balance that charge out. So arsenic acid is then H3AsO3. Example 7, hydrocelenic acid. I have hydro and ic, so that means the original ending would have been ide. So they added a hydro, so I'll take that off. I'll have to change ic back to ide, and then I get rid of the acid that was added. And that leaves me with selenide. So I look up selenide on the negative ions list, and I find Se with a 2- charge. Since I have a 2- charge, I need to place 2 H pluses before the selenide to balance the formula. So hydrocelenic acid is then H2Se. Example 8, chromic acid. I have ic, but I don't have hydro. If I don't have hydro and ic, then the original ending cannot be ide. Since it's just ic without hydro, that means the original ending was ate. So chromate is what I look up on my negative ions list, and that is CrO4 with a 2- charge. Since I have a 2- charge, to balance it out, I will need 2 H's on the front of the formula. So chromic acid is H2CrO4. Example 9, CH3COOH. Right off the top, you may have noticed that this looks different than the other acids. And that's because we were told all acids have H plus at the front of the formula. But we clearly don't have any hydrogen at the top of this formula. Now, why is that? The H is actually on the back. But why is the H placed on the back of the anion instead of the front like all the other acids? And that's because this is an exception. This is an organic acid that is very popular in chemistry, so we have to be familiar with it. Organic chemists like to write the formula the way that the elements are bonded to one another. If I were to draw this formula, it would look like this. The first C is connected to 3 H's. The second C is connected to an O and an OH. So they place the H at the back because that is where it is connected to the molecule. If I look this up on the negative ions list, I find CH3COO-. That is called acetate. Since it ends in ate, we change ate to ic, and we follow with acid. So CH3COOH is known as acetic acid. Again, very popular acid. You probably have this in your house because the generic name for this acid is vinegar. And that's the end of the lesson. You're good to move on to the assignment.